Okay, so this is the video that I was telling you about that I was going to do last week today. And that's where I want to talk about smokestacks and I guess their effects on the environment. Because someone mentioned that I should cover it. So, here I am. Let's do it, let's jump right in, and let's roll that intro. For those of you who don't know, smokestacks are typically large pipe-like chimneys that tower into the sky, and what they do is they'll remove smoke and gas from the building while they're combusting whatever it is that they want to combust. These smokestacks will typically reach roughly 900 feet into the air. The reason why smokestacks are built so high up into the air is because they have to remove a lot of smoke and pollution into the atmosphere. And what this means is that they have to be above a certain point, and this point has to be above the inversion layer. What I mean by the inversion layer is essentially the temperature difference between the ground and the sky, right? There's a temperature gradient. And this inversion layer is a layer of stable air. If it's within that layer, the pollutants get stuck. If it's above that layer, they have the ability to catch wind and fly off somewhere else. Not good, but it's better than having it sit in an area and build up over time. Because of the height of some smokestacks, these require specific lights in order to keep air traffic in that area aware of that smokestacks are right there. If it's in a high air traffic zone, they require flashing lights to let air traffic know that these are towering in the sky and they've got to, increase elevation. What's produced in these smokestacks is generally particulates of either microscopic solids or liquids or larger versions of particulate matter. The most used commodity typically in these combustion procedures is coal. However, there is oil, there is natural gas, and there's also municipal waste products, or municipal solid waste products, to be more specific. In general, the burning of coal in these smokestacks will produce quite a lot of gases and chemicals when combusted back into the atmosphere. These are carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxide, mercury, arsenic, and benzene. Whereas the burning of natural gas will produce carbon dioxide, carbon monoxide, and nitrogen oxide back into the atmosphere. Oil will produce pretty much the same amount of pollutants or the same type of pollutants as coal will. All of these. Municipal solid waste products will produce a myriad of pollutants. I'm going to try and remember them all. Let's get it. Sulfur dioxide, hydrogen chloride, particulate matter, carbon monoxide, nitrous oxide, cadmium, lead, mercury, dioxins, and furans. That took a while to remember. All of these pollutants that I have mentioned all have their own unique way of dealing with the atmosphere, as well as their own way of basically being super harmful to both the environment and us. In fact, some of these pollutants actually can kill us if inhaled in large quantities. The combustion of all of these pollutants or chemicals into the atmosphere has a huge stress on the atmospheric carbon cycle as well as the greenhouse gases. What I mean by this is that a lot of these chemicals that are produced affect the natural greenhouse effect in the atmosphere, essentially creating a thicker blanket and trapping heat over time. So the greenhouse effect is where the sun's solar radiation is reflected onto the Earth's surface, which then gets bounced back into the atmosphere and then sometimes trapped by the greenhouse effect or the greenhouse gases that cover the atmosphere and bounce back into the Earth. This heat energy is then used to warm the planet to a temperature in which allows life to exist. The issue here is that human activities, mainly the burning of fossil fuels such as coals, oils and natural gas, as well as land clearing and agriculture, are pumping an excess amount of greenhouse gas chemicals, or gases I should say, back into the atmosphere, creating a thicker blanket, trapping more heat over time and warming the Earth faster than adaptation can handle. Some of the noxious gases produced by smokestacks actually react with the ozone as well as the water vapor in the atmosphere, creating a new chemical which depletes the ozone layer, which is not good for us. Sulfur dioxide, remember I mentioned that before, readily reacts with water vapor in the atmosphere, turning into sulfuric acid. Sulfuric acid is the main component to acid rain. But one of the cool things about sulfuric acid and acid rain is that it reflects more heat back into space, meaning that it cools the Earth better than most of the greenhouse gases in the atmosphere. Now, what scientists are trying to do are artificially create more of these sulfuric acid components and flush them into the atmosphere to artificially or geoengineer a cooling process for the planet. The problem here is that if that happens, there is a possibility or a potential that they could affect the natural cycle of rainfall and storm events globally. Nitrogen oxide is probably one of the more potent gases being released by smokestacks. Nitrogen oxide is 300 times more potent than CO2 in the atmosphere. To put that into perspective, 0.45 kilograms or 1 pound of nitrogen oxide will warm the planet faster or 300 times faster than CO2 of the same amount over a 100-year time span. Furthermore, when nitrous oxide reacts with the ozone in the atmosphere, it will transform into the nitrogen oxide, which also depletes the ozone layer. So you've got it being 300 times more potent than CO2. You've also got the nitrous oxide transforming it into its nitrogen oxide, depleting the ozone layer. Not a great chemical to have up there. I'd probably say it's worse than having excess amounts of CO2. Put it out there. Carbon monoxide, which is in most components of fossil fuels, is more so potent to a lot of humans. Not so much to the atmosphere or to the planet. It's more potent to us. It can kill us if inhaled in large quantities. This is because carbon monoxide has the ability to bind to hemoglobins and transform them into carbon oxyhemoglobins, meaning they'll replace the oxygen content in your bloodstream, meaning that depleted oxygen blood will go to a lot of your primary organs, more so the heart than anything, and kill you from lack of oxygen in the blood. But you'd need to be exposed to some ridiculous amount for that to happen. So don't fret, unless you're like sucking that bad boy in through a tube, then you probably should be scared. So smokestacks are bad. Okay? Okay. They release a metric ton of pollutants into the atmosphere. But modern day smokestacks are not that bad. What I mean by that is that modern day smokestacks have or currently are implementing ways to capture these pollutants and decrease their output onto the planet. Electrostatic precipitators, which are used in the majority of these smokestacks or modern day smokestacks, have two electrodes. One to produce a negative charge, two to capture the negative charged particulate matter that's of interest. This usually targets smaller particulate matter more than anything, but it's been said to produce smoke that's 90% free, or roughly 90% free of pollutants. So that's pretty good. Fabric filters, not used as much, still used, have a porous filter that the smoke travels through and captures any small particulate matter that's trying to pass through. Venturi scrubbers utilize a tube and water pressure. So pressurized water will pass through a tube, capturing any particulate matter within that smokestack. Once that happens, the pressurized or water vapors or water droplets fall to the bottom into a dropper, get captured, and then removed. The problem here is it uses a lot of water. I mean a lot of water. Cyclones, as the name suggests, utilize the wind speed and pressure of a cyclone. Crazy. What happens here is it'll spin past, pick up large particulate matter, drop it in a hopper, take that hopper, and that's about it before it's emitted. Problem here is it only captures larger particulate matter, so you'd need to combine it with something else to capture the small ones. That's how we remove it. That's how we clean smokestacks, or clean emissions from smokestacks before they're emitted. Pretty cool. Okay, so that is that. I hope you enjoyed it. Make sure you like, comment, and subscribe. I'll see you guys next week for another video. And yeah, smokestacks, kind of bad. Modern day smokestacks, not so bad. You be the judge. I'd say they're all pretty bad. Just pumping anything into the atmosphere. Anyway, make sure you like, comment, subscribe. See you guys next Wednesday for another video. And educate, don't eradicate. Check out Cape Class down below. Awesome organization. See you guys next time.